Welcome to today's webinar, Optimizing the Data Tier for Serverless Web Applications. Our presenters today are Prahlad Rao and Balaji Iyer. Prahlad is an Enterprise Solutions Architect at AWS, where he helps customers navigate their journey to the cloud. He is a hands-on technologist with 19 years of diverse experience across enterprise architecture, IT strategy, and operations. Balaji is a member of the Amazon Web Service Professional Services team. He has helped several Fortune 500 customers successfully navigate their journey to the AWS. His specialties include architecting and implementing high scalable distributed systems, serverless architectures, infrastructure as code, application development, and leading strategic initiatives like the AWS Well Architected. Today we also have Stefan Menes and Peter Dalabunjan, and we have Vamshi Ankam, who will be our moderators today throughout our call for your Q&A questions. Prahlad and Balaji, welcome. The floor is now yours.
Thanks, Jerry. Hi, everyone. My name is Balaji Iyer. I'm with the Professional Services team. Thanks for joining us today. As we all know, every web application needs a data tier. We have to choose the appropriate data tier based on your workload pattern. So it depends on whether you use SQL or NoSQL, whether you're trying to add a caching layer in front of your database, and also you're trying to answer some important questions. How can I scale my data tier? How can I provide low latency and fast performance to my database? The goal of this session is to help you make those decisions and select the appropriate data tier configuration settings around optimizing those choices that you're trying to make. We will also look into some configuration guidelines around runtime, caching, and retries. So we're going to start with a quick look at the anatomy of a typical serverless application. So we look at a couple of different patterns, web application pattern and a mobile application pattern. And then we will kind of deep dive into how Lambda integrates with each of the data tiers, DynamoDB, RDS, and ElastiCache. Then we will wrap it up with additional best practices and some design considerations, and also for caching and retries. Let's get started. In a typical web application architecture, you have a three-tier application pattern, right? In this case, your web tier is going to be surfaced by Amazon API Gateway, and then there's Amazon Cognito User Pool. Amazon Cognito User Pool provides a highly scalable user management service. So in this case, where you can actually manage users, you can also have users respond to a certain initialization email, and then based upon that code, you can allow access to your website. So in this architecture, what I'm showing here is an example of a blog site. In this case, your front end is serviced by Amazon API Gateway. Your middle tier, the logic tier, is the AWS Lambda, and your data tier is going to be one of these choices, DynamoDB, ElastiCache, or RDS. Let's walk through an example. When the users want to sign up to your blog site, they connect to your blog site through the API Gateway interface, and then they sign up with their email ID. And if you look at the top, there's an AWS Lambda function that triggers for signups. In that case, they will get a notification email with a code where they can further use that code to enter to get authenticated to your blog site. So after they get authenticated, get that email, they will connect to the blog site, and your Lambda code gets executed, and that's going to connect user-specific information from databases choices that they have. So this is a typical example of what you would see in a web application that is using the serverless methodology. Let's look at another application. In this case, it's a mobile application. It could be an actual app on your phone, or it could be a URL you're connecting through your mobile device. The front end is going to be surfaced again by Amazon API Gateway. The middle tier is going to be Lambda in this case. And same database tier patterns. If you notice in the last two architecture patterns that we saw, there are no servers. You're not setting up and managing EC2 instances. You're actually using AWS Lambda, which has no servers configuration required. And you're using fully scalable and highly managed database options that are provided to you. This is a very common typical pattern that you see customers embracing serverless technologies, where you don't have to manage the network or the servers or the underlying infrastructure that are assuming as part of running that infrastructure. And you're using highly scalable and 100% managed services like RDS, ElastiCache, and DynamoDB. Let's look into some of the data tier options that we have in AWS today. We have multiple options for data tier. The first one is going to be the Amazon DynamoDB. It's a highly scalable document and key value store. If you are using NoSQL type databases, and this is a very popular choice because it is a document and key value store. Another option is Amazon ElastiCache. Whether you're using Redis cache or Memcached, ElastiCache provides in-memory key value store option. If you're using a transactional or a relational database, Amazon RDS is a fully managed SQL database engine. Other option is the Amazon Redshift. It's a highly scalable petabyte data warehouse. For the purposes of this session, we're going to focus on Amazon DynamoDB, ElastiCache, and RDS. One choice you got to make early on is whether or not you're going to be using SQL or NoSQL. So what are some of the things that you have to consider to really make that choice? Whether it depends on your data. What type of schema does it have? Is it a partial schema? Or are you trying to focus on performance and availability at scale? You have multiple data sources and that are dynamic in nature trying to connect to your database. Is your data denormalized in nature? And you have to maintain and manage a high volume of data ingestion that is coming to your system. So in that case, NoSQL is your choice of database. On the other hand, is your database complex and relational and transactional in nature? Is there a strong schema dependency between the data sets? Are you trying to focus on asset principles and focus on also availability? Another thing to consider too, whether you have a system that uses SQL Server or SQL tables that have tools that understand SQL automatically, or are you trying to run complex queries on your database? And in those choices, SQL would be your choice. You may be wondering, what if my data supports NoSQL, but I have a lot of tool sets that automatically understand SQL? What do I do in that case? In that case, you have to sort of weigh in the choices between the pros and cons of using your relational database system in a NoSQL manner or a NoSQL system in a relational database manner. Let's look into some of the top Amazon DynamoDB use cases. Ad tech is really popular for DynamoDB use cases. For example, you have to have a millisecond latency or even a microsecond latency to surface your ad, and that's the time you have to determine what ad you're going to place. Or you have an IoT system that consists of hundreds and thousands and millions of devices trying to send data in real time. We have demos for each of them. We'll be able to show the IoT example. Or you're trying to manage a dynamically changing and evolving game board, leaderboard, where you're trying to manage that across your multiple game sessions based on session information and gamer information. Or you have a web application or a mobile application similar to the pattern that we saw before. You're trying to manage the session details, user profile information, for example, a blog. You're trying to get user-specific specific information and trying to surface that. In that case, these are the very common use cases for DynamoDB. So how does AWS Lambda integrate with DynamoDB? So one of the obvious benefits here is there's no VPC configuration required. Because it's a serverless, there's no VPC configuration required. However, you can have your Lambda function configured in a certain way where you can have access to the VPC resources. In the Lambda configuration, in that choice, you select VPC or no VPC. So you have fine-grained access control. For example, you want to give your users access to specific rows or columns in your database. In your DynamoDB table, you can accomplish that using DynamoDB. And you're using role-based mechanism that is offered by IAM. From the performance perspective, DynamoDB offers a very simple API model. There are roughly about 15 different API commands that is available for DynamoDB, like create table, insert table, and so forth. Another benefit of that is concurrent connections at scale. If you have a user connection that is exponentially growing, so you can have your DynamoDB configured in a certain way where it can handle concurrent connections at a growing scale with your users. And you get a consistent query performance with the volume growth. You're not going to see lag when the volume growth, as the volume growth increases. You can configure in a certain way where you don't see a lag time between your volume growth and the spikes that you're seeing with the user. And if you're seeing there's a performance lag, you can simply dial up the capacity with a click of a button or using an API or SDK call, and you have that available. DynamoDB is a persistent data store. It can provide single-digit millisecond latency. So what if you want a single-digit? What if you want a microsecond latency, like for example, like an ad placement? In that case, you can complement DynamoDB with the ElastiCache layer in front. It is a caching layer, so it will increase the performance from a millisecond to a microsecond latency. Now I'm going to hand over to my colleague, Prahlad. He's going to talk about RDS.
Thank you, Balaji. Good afternoon, everyone. So we just saw some configuration related to Lambda connecting to DynamoDB. Over the next few slides, I'm going to be focusing on two data store, which is RDS, which focuses on relational databases. Typically, if you require data structure, asset consistency, you would want to look for a structured database like commercial database, open source database like MySQL, Oracle, SQL servers. That is when you would need a relational data source. As we all know, some of the applicable use cases involves e-commerce, traditional IT applications, websites, and reporting applications. I want to take a quick minute to talk about Amazon Aurora. Amazon Aurora is Amazon's fast and highly available, fully compatible, MySQL compatible relational database. We also recently announced 100% support compatibility for Postgres as well. So that means now you can easily run MySQL and Postgres database using our Amazon Aurora database. Amazon Aurora provides faster and highly scalable database. The way that we have designed our Amazon Aurora, which was written 100% from ground up, was to divide or separate out the SQL and the transaction layer from the underlying data store, which means that you have independent scale from the underlying data store as well as from a SQL transaction layer. And the data is 6-way replicated across multiple availability zones, up to 3 availability zones. And then it provides immense scalability for up to 64 terabyte with 15 read replicas. So those are some of the key characteristics of using Amazon Aurora. Now let's go into some of the configuration related to how Lambda can interact with a relational database. While Balaji talked about how Lambda can integrate with an Amazon DynamoDB, which is a NoSQL database where there's no VPC configuration required. However, when you're having Lambda talk to a relational database within your VPC, which means that since your relational database lives within your VPC, there's a specific configuration that is required on top of VPC, on top of the Lambda that you need to enable in order for the Lambda functions to talk to any resources within your VPC. For example, when a Lambda function is invoked, it has default access to internet. That means the Lambda function can talk to any resources outside of your VPC, can also talk to any of your applications that are residing on your on-premise infrastructure. However, when Lambda needs to talk to resources within your VPC, let's say, for example, an RDS database, EC2 instance, or an ElastiCache resource, you need to set some configuration. Some of the key configuration required are setting up the appropriate VPC subnet IDs and the security group for your Lambda configuration. I'll show that in a minute when we walk through the demo. Additionally, Lambda function also requires an IAM execution role so that the Lambda function can talk to the resources that are residing within your VPC. So you see the Lambda execution role that's listed in the parentheses. You can enable that for your Lambda function and then set appropriate permissions and authorization so that it can talk, read, and write and communicate to the resources. In addition, make sure that your security group inbound rules allows connection from the Lambda onto the VPC resources. A couple of other points to remember here is when you enable VPC access to your Lambda function, that means you're also enabling access to any of the peered VPCs that the VPC is part of, including VPN endpoints and private S3 endpoints. That means when the Lambda has permissions to connect to your VPC resources, it also has permission to all these additional resources. Also, just want to give a recommendation here is when you make sure that you enable VPC access for Lambda only when you require. That means if you don't require access to your VPC resources, for example, if the Lambda is talking to DynamoDB or maybe any external resources that lives outside of your VPC, then there's no need to enable the VPC functionality for Lambda. There are a few other configuration as we see here. When you enable a Lambda function access to a VPC resources, that function automatically lose access to internet. That means any resources that are residing outside of your VPC, Lambda will not be able to access that. So how do you actually maintain access to both resources outside of your VPC and within your VPC? How can you do that? By enabling or by configuring a NAT gateway within your VPC so that the Lambda function can talk to any resources outside of your VPC through a NAT gateway, and by enabling the VPC configuration, you can achieve both functionality wherein the Lambda can talk to both VPC resources as well as outside VPC resources. Also make sure that you have enough IPs that are within your subnet so that when Lambda gets invoked, talk to your VPC, it automatically creates and assigns an elastic network interface for your Lambda function to be able to talk to both your VPC resources. One other pointer to note here is if you have resources within your VPC, try to use its private names or IP address as much as possible, avoiding public host name resolution, because that will add additional millisecond time to your Lambda function because it has to resolve your DNS functionality, get the DNS mapping, and then be able to resolve the resources. So whenever possible, if you're accessing a Lambda or if you're accessing a VPC resources from your Lambda, make sure that you can connect to it through its private host name or an IP address. From a performance characteristics perspective, it's important to understand that you need to choose the right RDS instance type for high Lambda concurrency. Because of the nature of the Lambda invocation, we are expecting that there will be high concurrency for Lambda to be invoked or to be communicating with your RDS instance type. So make sure that you provision an appropriate RDS instance type. For example, if you're invoking thousands, 10,000s of Lambda connections to your RDS database, it's appropriate to configure an appropriate database instance type. So make sure that you configure the right instance type. For example, if you're configuring the 10,000 concurrency, it might not be a good idea to configure, let's say, an RDS T1 instance type, right? So make sure you set that, you put the design aspects when you're configuring Lambda to talk to an RDS instance. Alternatively, if you have a different instance type and high concurrency rates from the Lambda, you can use something what we call as a kinesis sandwich, where you're putting a kinesis stream after your Lambda function, and then that kinesis stream will actually buffer your Lambda concurrent request, and then that will be put onto another Lambda function, and finally it ends up to your backend database tier. This gives you a different throttle where you can tweak and tune a different throttle on your backend database if the backend database is lower compared to the incoming concurrent request that Lambda is sending to. So make sure that you can also incorporate some of these best practices there. One other good practice is to instantiate database connections outside the scope of handler. So when you're actually writing a Lambda function, make sure that any of the persistent connection, for example, connecting to a database endpoint, maybe a different endpoint, or invocating additional initialization parameters, you can set that outside the scope of the event handler so that the consistency or the connection is maintained when you invoke subsequent Lambda invocations to your backend database. Or you can also look at maybe using some language frameworks like Node.js, Next, and SQLize that are available so that it maintains consistency or persistency with your database connections from your Lambda. Also make sure that you fine-tune the max connection setting for each database instance type. Keep in mind that every database instance type has different max connection settings. So when you are invoking Lambda connection to a T1 database versus a C1 database type, each has its own max connection setting. So make sure that you tweak and tune appropriately for your Lambda functions. Now what I'm going to show you is a quick demo of how you can use Lambda to talk to both resources within your VPC. I'm showing a demo that Lambda can talk to Aurora database within a VPC and also use KMS, which lives outside of your VPC, so that the Lambda can talk to both resources within your VPC as well as outside your VPC. So here we are encrypting the database password file. So when a Lambda needs to talk to an RDS database, one thing you need is database credentials, which is username and password. Obviously, you don't want to package your password file in clear text within the Lambda function, in which case you would need to encrypt the database password file. What we are utilizing here is utilizing AWS KMS in order to encrypt and decrypt the password file, and then you can, once the password file is encrypted, you can package the password file within the Lambda and upload it to the Lambda package. After that, when you invoke the Lambda functionality, it calls the KMS endpoint, decrypts the password, passes that variable back to the Lambda function, and then that way it is able to connect to your database. All that can be invoked through a Lambda code that I'm just showing it for you now. So let's switch to the demo mode now. I'm going to share my screen here. So let's go ahead and share the screen now. I'm going to open a console here. Hopefully the console is clearly visible. I've tried to increase the font size. So here we have a simple Lambda function. And the Lambda function, let's take a quick look at the Lambda function. It's written in Python. As you can see, I'm importing Boto3. I'm also importing PyMySQL, which is required to connect to the database from a Lambda function. I also have the RDS Aurora endpoint listed here with the appropriate variables defined for DB name, DB username. So this function, what you're seeing here is a simple function which actually decrypts the password file from KMS endpoint. So we are actually calling the decrypt, and then we are using the ciphertext blob, and then be able to decrypt the password that we have encrypted ahead of time. You can also look at some of the other code here where I'm trying to connect to the KMS endpoint with the appropriate master key ID, and then I'm running a simple database connection string where I'm creating certain string table, for example, employee ID, name, and certain values here, and also executing a select statement from the database. So I think that's all I'm doing here within the code. It's a simple functionality that demonstrates how you can use Lambda to connect to a database within a VPC and also be able to access KMS, which lives outside of your VPC. Now within this package, one thing we need to do, as I said, we need to encrypt the password file and then put that within the Lambda package. So what I'm going to do here is I'm going to use the KMS command to encrypt the password file. So what you're seeing here is an RDS password config file that has a clear text password. Obviously, I'm not going to show that here, but what I'm doing here is, I'm going to issue AWS KMS encrypt key command. Copy that, let's copy that, and then paste that here. So the KMS command encrypts the clear text password file using the ciphertext blob and base64 encoded, and then it provides an encrypted RDS password config file. So let's run that command. Now we have run that command. That means now we have KMS encrypt the password file for us. So if I do a file on encrypted, so this is a PDP11, this is an encrypted key file. Now I'm going to copy this encrypted file within the Lambda package. So I'm going to put that into the Lambda folder. Let's go to the Lambda folder. Now as you can see, this package or the Lambda folder also contains the encrypted key file. Now I'm going to package this, zip it up. So let's go ahead and run the zip command. I'm going to run the command, zip the package, Lambda package folder. So now we have the RDS lambda.zip folder, right? The zip file. Now let's go ahead to the Lambda console. I have the create table records. And now I'm going to upload the zip file that we just created to the Lambda console. Let's go ahead and save that. So now the package is uploaded. It's saved to the Lambda console. Now let's go ahead and run or invoke the Lambda function. I'm going to invoke the Lambda function now. So it's a simple invoke where I'm invoking the Lambda function, that's the function name, and I'm selecting a region and also creating an output text file that shows that all the records that was inserted after the function has been run. So let's go ahead and run that. So you can see the first invoke takes a little bit of time because of the invocation instantiation of the Lambda function. So once the function, you can see the status code of 200, which means it's a successful Lambda invocation. Let's quickly look at the output text file. You can see that these number of items were added to the RDS table. Now let's also confirm through the console, go to the CloudWatch and then look at, make sure that the new records were added to the Lambda, to the RDS table. As you can see here, now this CloudWatch metric shows all the records that was added to the RDS table by invoking the Lambda function and also using KMS to encrypt and decrypt the database password file. Towards the end, it also gives you the report of some of the statistics here that says the duration the Lambda was run. It ran for about 9 milliseconds, and then the build duration and the memory size it consumed and so on and so forth. So pretty useful information in order to get the usage statistics of the Lambda function. So let's go back now to the presentation mode. All right. Now we saw how Lambda can be invoked to talk to an RDS database within your VPC and also talk to a KMS endpoint. Let's progress through ElastiCache. So I think typically when we talk about caching, we always think about introducing a caching layer in front of your database so that it can improve read performance for your underlying database. But however, there are various use cases for ElastiCache. Namely, you can use ElastiCache, namely Redis and Memcached, as a NoSQL data store purely running on top of memory. That means you are using a NoSQL database running in memory, which gives you single-digit microsecond latency for your data stores, right? So as Balaji mentioned about how you can use a NoSQL data store like DynamoDB, which is disk-based, you can use the same data store, but use ElastiCache in front of DynamoDB in order to improve your Amazon DynamoDB performance by caching all the data with an ElastiCache layer in front. So ElastiCache has various use cases, not only in terms of improving your database read performance, but also using that as a ephemeral key value data pair as well. Namely for high performance application patterns such as leaderboards, session management, event counters, and so forth. So we'll run the same scenarios as from a configuration and performance perspective in order to connect Lambda with ElastiCache. The ElastiCache configuration with Lambda is pretty much the same because ElastiCache resources reside within your VPC. You need to follow the same configuration that we just saw, wherein the Lambda configuration needs to have a VPC configuration set. It also needs to have a NAT enabled if it needs to access resources outside of your VPC. You can simply use IAM roles for access and authentication, where you don't need a database username and password like what we use for database authentication. This is much simpler here in that regard. In addition, you can also leverage additional libraries like PyMemcache, Node Discovery, so that it can be used within your client application in order to talk to your ElastiCache resources from a Lambda function. From a performance perspective, since ElastiCache can invoke concurrent connections at scale because it supports 10,000s and millions of connections from your Lambda to ElastiCache, it provides high performance data store for your Lambda functions. In addition to that, always recommended to use Redis pipeline to maximize number of operations per second. As we all know, Redis is a TCP-based request response systems. That means when you send a Lambda request to a Redis data store, Redis data store will queue the request and then process that and then send the response back. Well, it works when you are issuing maybe hundreds of concurrent requests. But what you have, let's say thousands or 10,000 Lambda connections that are invoking your Redis data store. In which case, if you enable pipelining, the Redis pipeline will allow you not to respond to each and every request sequentially, whereas it will queue all the requests, and then it will process that in parallel so that it can send responses back to your Lambda function parallelly. That means there is no queuing, there is no serialization that happens, wherein the performance for the Lambda back to your ElastiCache is significantly improved. It is also important to select the appropriate instance type for ElastiCache, similar to database, but it's much easier to scale because a single instance ElastiCache can support up to 25 to 30,000 concurrent requests. So it's much easier to handle scale and concurrency when you're using ElastiCache with Lambda. Typically, Memcache is pretty good for read-heavy workloads, whereas if you're looking for both read and write-heavy workloads, you can look at Redis, which offers better performance for write-heavy workloads. In addition to that, the other way is also to make sure that move data structures outside of your web apps, like for example, persistency, connection pooling, and all and other parameters that you can move outside of your web apps two more like ElastiCache data store tiers so that you can get the performance benefit without having to store session management within your web tiers. The other good practice is instead of updating the cache every time there's a write activity on our backend database, you simply invalidate the cache tier and let the readers or the client application update it. You can set the client application to actually write to your ElastiCache simultaneously when it is writing to your backend database tier. So instead of the backend database tier you're writing logic to move the frequently used data back to the cache tier, you simply invalidate the cache tier so that the client application handles writing and reading back from both the cache tier as well as the backend database tier. Now I'm going to hand over the session to Balaji, who is going to show us some cool demo of integrating Lambda with ElastiCache and also take us through the rest of the slide deck. Thank you. Balaji, up to you.
Thanks, Prahlad. So let's take a look at the architecture in front of us. So it's, again, a three-tier architecture pattern that is very familiar as we saw in the beginning of the talk. So in this case, the front end, we're using API Gateway, and the middle tier is going to be a Lambda, and then there's going to be ElastiCache on the back end. So we're going to show a couple of different examples. The first one is going to be with API Gateway as a front end. Another one is going to be using IoT as the front end. On the backend side, we're going to also see two different demos. One is using Memcached, and also one is with the Redis cluster. So let's go take a look at the demo. I'm going to go ahead and share my screen. Okay. So in this case, let's take a look at the front-end part. So I have an API Gateway endpoint. So this is the API Gateway endpoint that in your case would be a web application or your customers can connect to, or any application that of your choice. My middle tier is the Lambda function. Let's take a look at the Lambda function. So I'm importing libraries. You could actually import third-party libraries. You could import libraries from a different team in your organization. In that case, you can zip up that library binaries in your package like we saw in the RDS example, and you can actually use that as part of your Lambda function. So in this case, here's my Memcached endpoint, and I'm defining it outside of the Lambda handler. This is one of the performance tips for Lambda because as you could see in the code, I'm not closing the connection. Typically from a software development point of view, when you open a connection, you would actually want to close it. But in this case, we are not going to close the connection because of container reuse. So what happens in the back end when you connect to this endpoint and the Lambda executes this functionality and you trigger the Lambda function again? We reuse the connection. We try to reuse the connection on the back end, so offering you improved latency and better performance. So in this case, I'm connecting to the ElastiCache endpoint, and I'm doing a very simple get set value. So I'm setting a value. It's a UID value, some random value, and I'm returning the value. On the back end, I have ElastiCache. It is a fully managed Memcached database. And once you click on that, you could actually see a lot of metrics that are specific to your Memcached cluster. All this information is just available to you just as you click on that link. So having seen that, let's go look at the demo. So when you invoke this node, for example, what happens? So what's happening in the back end is it's what you typically call as a cold start. Why is it taking so long? Is that your application being delayed, or is that the Lambda is being in a cold state? So the question is, you're trying to answer is, how can I improve the performance of this? So how can I make this connection return the results as fast as it's possible? So obviously, in the second time invocation, it's faster, right? Let's open an incognito mode and see what happens after. So it's obviously a lot faster this time, right? So what's happening in the back end is it's what we typically call as a cold start. When you invoke the Lambda function for the first time after a long time of not using it, and you get into that state where you saw it took a few seconds for us to return the results. And subsequent invocations are faster. So in that case, the Lambda function is in a warm mode. meaning we already have the containers on the back end. We try to reuse, and we serve that records right off the container. So typically, how do you architect your solutions to take advantage of the warm start? So in the Lambda function, there's a trigger functionality available for you. So in this trigger, you can actually schedule a Lambda function using CloudWatch event schedule, and you can schedule it to run any frequency as you want. You can run it 1 minute every hour, once a day, multiple times a day, depending on your user pattern who are going to be connecting to this. So before your user connects, let's take an example of your weather type situation. Anytime there's a bad weather warning, and you actually see if you're a weather site, and you will see the connection spike up. So anytime there's a warning that appears, you want to actually keep your Lambda functions on a warm state. In that case, you're seeing a better performance for your customers. So these are other ways where you can keep your Lambda functions in a highly available performance state where you can scale up the load and start serving your customers right off their requests. And also, as you can see in the advanced settings, there are multiple memory options. There are about 20 plus memory options. Feel free to play around with those, and also the timeout, because your ideal performance for your application is going to be determined by using the memory and the scale, the number of customers that are going to be connecting to your website, and so forth. And this is the default VPC setting. In this case, you can actually use the VPC resource, or you can choose no VPC on that resource. So that is the Memcached demo. Let's take a look at the second demo that I have for you. It's using IoT. In this case, what I have is an IoT sensor hub. In this case, I have a lot of IoT devices that I'm simulating that are sending in data like temperature and humidity. So in AWS IoT is a fully managed IoT service that can scale up to millions of devices and billions of transactions using messages using MQTT protocol. So here you could see I'm sending some data real time with the device ID, temperature, and then the IP. These are random values that I'm simulating in my code. So here's the MQTT client where I can actually see what are the messages that are coming through this. So that is my front end. So what's happening? How am I invoking the Lambda function? The results, anytime there's a new data that's going to be coming into that topic, temp_readings, I'm going to trigger a Lambda function on the back end, which is going to be executing the code, the business logic that is behind it. So let's take a look at the business logic behind it. So this is my middle tier. As you can see, in line number 14, I'm connecting to the Redis cluster, and I'm performing some basic functionality based upon the temperature value that I'm getting. If the temperature is more than 90 degrees, I'm setting a value as hot. If it is between 80 to 90, I'm setting it warm, and so forth. And if it's below 65, I'm setting the temperature as cold. Right. This is all I'm doing. I'm saving that data into my Redis cluster. So here I have my Redis cluster that is storing all the values that is generated, that is connected to the Lambda function. So in terms of the actual simulation, this is kind of what's happening in that instance. I'm simulating all this data, and in this case, I can connect to my Redis cluster and run simple commands like give me some data about this particular node. This is my device ID. So here I can get specific information from that device, and also give me a set of top devices that are connected to my IoT hub, and also give me the coldest device ID. You can do warm. You can see specific information. Now in this case, I'm actually querying the Redis cluster that is connected to this instance that is saving all the data, and I can query this in real time. So from an end-to-end perspective, so you are using IoT for ingesting the data and Lambda to process, and using ElastiCache to connect in the back end. And you want to have some kind of a mechanism where you can visually see all that information in real time, right? So in this case, I have a Elastic Beanstalk application that is a simple web application that renders a dashboard sort of functionality. It's very minimalist in kind of what it does, but this is to demonstrate what is really possible with using services like this. So I'm getting temperature data in real time from all these instances. If it is beyond a certain threshold, I can send notifications in my notification bar. And over a period of time, I can see how many devices that are connected to that are showing a certain temperature parameter, right? And another interesting thing to note about in the Lambda function is you can go to the monitoring tab and actually see lots of interesting information about your Lambda function itself right at your fingertips. So you can see a number of times the Lambda got invoked, and then the duration it took for Lambda functions, and if you have any errors in your function itself. And in this case, I scaled up just before the demo, so you could actually see your spike over time, and it's highly scalable. In this case, you're paying the number of invocations per every time you invoke a Lambda function. There's a cost associated with it. I think the latest pricing is for 1 million invocations, it's 20 cents. So you can see like it's a very economical value, and also you're getting a lot of scale and availability and the dynamic nature and fully managed services like ElastiCache and IOT and Lambda by using that platform. That's the end of the demo. Let's go back to the slide deck. So we're going to see some couple of additional best practice configurations, some configuration settings that you could use, and also caching and retry tips. So Lambda essentially is an independent stateless threads. So there's no state associated with Lambda automatically. There's a step function functionality that we recently launched in reInvent. You can take advantage of state management across your Lambda functions. So when it comes to caching, in the first example that we're going to see here, you want to make sure you initialize the database connections outside of your event handler. We saw this in the demo. We have the connection to the Redis cluster or the Memcached cluster outside of that handler function. This allows the connection reuse, and you could see we're not closing the connection after we are done with it. And when you initialize the code before handler for the first time, and there's a cold start, there's a warm start, and you want to make sure you test that functionality out and make sure you have some kind of a trigger that can keep your function in a warm state. You could also use the container in other ways, like for example, when you're downloading a function, let's say for image processing, for transcoding a video or similar workloads, you don't have to download it every single time because you're letting the connection reuse. So Lambda is smart enough to know that this container was served this particular functionality before, and it's going to associate that container again. So in that case, you will find that downloaded file that's already there in the temp space. When it comes to retry and event ordering, since Lambda is a stateless nature, how can you handle retries and event ordering and so forth depending on what you're trying to accomplish? So let's take a look at the first example. If you're using a Lambda function in a synchronous manner, using API gateway is a synchronous method of accessing Lambda. So in that case, you can use the SDK, or you can set the retry logic from the caller at the client side. The ordering is actually up to the caller in that point. So your retry logic will be done at the client side. So what if your Lambda invocation is actually asynchronous in nature? For example, you're invoking S3 or you're sending an SNS trigger in your Lambda function. As a default functionality, Lambda tries it for 3 different times, and then if it failed in all the times, the event is discarded. So in that case, you will have no record of what happened and how can there's a failed event, I want to be able to look into the event and actually do something with that event, right? So the ordering is also loosely ordered because it's going to be failed at random times and you don't know which one to process. So what we released during reInvent last year is a functionality called dead letter queue. what it does is you're going to let the Lambda function fail, and you can basically set a trigger and put that Lambda function that is failed into a SQS or a SNS for retry. So this lets you an ability to insight into the failed Lambda function and do some interesting things with it. For example, what if you have a stream data that's coming in your use case and you're trying to use Lambda function for that? So you can use Lambda for pulling a Kinesis stream. So in that case, your stream data would be a Kinesis stream or a DynamoDB update stream. And you will attempt to process the batch of records until you exhaust that stream. And the ordering is guaranteed in this one because it's a stream and you can process the order as it comes. That's what we had for this session today. Thank you so much for joining us. And if you have any questions, we will be at the Q&A session. We will be able to answer you through that. So now let's take a look at some of the questions that you guys have posted. So one question was, what is the performance difference between Java, Node.js, and Python? Excellent question. In terms of specific, the question is around language runtimes. So Python offers a better startup functionality, meaning the better startup latency. But we all know that once JVM is loaded, it offers faster warm options. And also, there's different memory configurations that you can test it out, your functions. Around 20 different memory options. You can change those memory options, see what offers the better performance for your application. And also, avoid unnecessary classes on your critical path. So your Lambda has to be, your critical path has to be direct in terms of what you're trying to do. And make sure you don't overload libraries. For example, when you're doing an import function in Lambda, using Python, it's very common for us to, because it's easier to just do import, yes, big library. But you want to be able to do import specific parts of that library, like import from this library and specific modules from that library. So that can help you the load time as well.
I think one of the questions asked was probably a few of them asked, will the code be available on Git? So yes, we do plan to make the code available on GitHub, the sample code. It's by no means very fully tested code, so just use caution in when using the code. But we are just, I think it's just meant to show the demonstrability of Lambda functions with VPC and other resources, including the IOT demo that we saw. But yes, we do plan to post the code onto GitHub and provide you updates there. Let's see, few other questions. I think definitely there are a lot of good questions there. And thank you to our moderators for answering all the questions. I think we have got a lot of it covered, but let's see if we.
There's a question about using Route 53 for the API gateway URL. Yes, you can do it. In this case, I'm just showing the Route 53. I'm not using the Route 53 URL. I'm using this API gateway endpoint. You can actually mask that and link that API gateway URL to Route 53 and route your traffic that way. So you can.
Yeah. So one more question I think would be useful is since Lambda is serverless, how do we control and get track if anything goes wrong and we won't be having access to the underlying server? Yes, that is correct. But that's why we have made available other tools so that you can effectively log and track and monitor your Lambda functions. One of the important integration is CloudWatch. As we just saw in the demos, I think in both the demos, we demonstrated that you can actually, when the Lambda gets invoked, you can also see on the Lambda console different metrics, whether there was errors, how many invocations and whatnot. And if you had a chance to look at the CloudWatch console, whenever Lambda is invoked, it will create the CloudWatch log groups, and then you can actually go inside the CloudWatch logs and then get to know if the Lambda function is failing, what was the reason, how long it took, and how long it ran, what memory it used, right? So we saw that in the demo. So yes, you do have metrics and monitoring capabilities for Lambda function through CloudWatch that you can easily analyze and go in detail of where it was failing and whatnot. In addition to that, I'd also mentioned the step functions where that gives you better control of how you want to invoke and manage different Lambda functions through AWS step functions.
Can you speak to an example of a highly performance architecture, 10K plus requests per second, and the Lambda's ability to scale, and what else could be suggested to support this architecture at a high level? So we have a lot of examples. If you go to Lambda case studies at AWS, we can share this link to you. There are a lot of customers using Lambda doing multiple invocations over 10,000 requests per second, and over millions and billions of invocations over time. And Lambda was able to scale automatically. You want to be able to make sure you have the memory settings that supports the Lambda function execution, and also the infrastructure needs. You can set up configurations in a certain way where you can let the Lambda organically or dynamically scale as per your customer's load.
There's one more good question there. So is there any way to trigger Lambda when there is a transaction trigger in RDS, for example, so that it can update and user via API gateway? Yes. So we also support triggering Lambda functions with integrating with Amazon Aurora database. So that means you can actually integrate Amazon Aurora database and then set triggers to invoke Lambda function when there is an activity within the database. So that means when there is a write or a bulk load or something within Amazon Aurora database, it can trigger a Lambda function, and then within the Lambda function you can call maybe other services, maybe call an SNS notification, or maybe talk to API gateway and whatnot. Yes. So you can integrate Lambda to trigger with an Aurora backend database. That means you can trigger for both MySQL as well as Postgres database. I think we are probably right to the hour mark. So I think thank you everyone for attending this session. Hope it was useful, and thank you very much.
I'd like to thank our presenters today, Prahlad and Balaji. Thanks for your time, a great presentation, as well as to Stefan, Peter, and Vamsi for answering the questions in the Q&A panel. If you have any comments on previous or upcoming webinars, or suggestions on topics you wish AWS to cover in future webinars, please feel free to email us at aws-webcast@amazon.com. Your feedback will help us improve our webinar programming. Thank you for the audience for taking time with us. Enjoy your rest of the day. You may now disconnect.